In this video, I'd like to think about negative exponents. So an example of that would be 5 times 10 to the power minus 3 in scientific notation. Now the general rule for that, I'm going to write this at the top, is that if we've got 10 to the power minus n, that is equivalent to dividing by 10 n times. So that's the opposite operation to what we had with the positive exponents. We're not multiplying anymore, we're dividing by 10 the number of times that are in the exponent of the power. So with our example here, so 5 times 10 to the power minus 3, that's the same as 5 divided by 10 divided by 10 divided by 10. So 1, 2, 3 times, which is 0.005. So it's the same as dividing by 1000. 10 divided by 10 divided by 10. And from our fractions last week, we know that that's the same as saying 5 times 1/10. 3 times, because dividing by a number is the same as multiplying by that number, by 1 over that number, sorry. So that's 5 over 1000, which is the same as dividing by 1000, which is 0.05. So again, that's all very well and good, but it's not very handy, is it, for working out how to convert between scientific and decimal notations. So we can move the decimal point in the same way as we did when multiplying, when using positive exponents. So taking our example of 5 times 10 to the minus 3 again. So this time we have to move the decimal point to the left rather than to the right, because we want the number to get smaller. We're dividing it, so we need to move the decimal point to the left. Now I like to write nice over to the right of my sheet of paper, because I'm going to have to fill in things to the left of my number. So 5 is the same as 5.0. So here's the decimal point, and it's 10 to the minus 3, so we need to move it 1, 2, 3 places to the left. Here's my decimal point. I need to write a 0 in front of that, and then fill in the zeros. So just as I got by my other methods, this is 0.05. 0.05, sorry. Let's have another example. 1.5 times 10 to the power minus 6. So I've got 1.5. Here's the decimal point, and we need to move it 6 places to the left this time. So 1, 2, 3, 4, 5, 6. Right here. A 0 in front, and then fill in the rest of the zeros. So that's 0.00000015. So now we're really seeing how scientific notation comes into its own, because it's quite hard to keep track of this string of zeros, isn't it? Alright, now let's do something the other way around. So let's say we start with something in decimal notation that's smaller than 1. So how about 0 in blue, 0.00002? Why not? Okay, so here we want the decimal point to be over to the right. And we could add extra 0 after there if we wanted as well. So to go from here to here, we've got to go 1, 2, 3, 4, 5 spaces. So that's 2.0 times 10 to the 1, 2, 3, 4, 5 minus 5. And so we can say that the general rule is that if you move the decimal point n places to the left, that is equivalent to saying times 10 to the minus n. Something else I'd like to say here is that, return to this example here of, so we've got 5 divided by 1000. So we can also say, which is 10 to the power 3. So we could equally say that, let's say number n, no, let's say b times 10 to the power minus a is equivalent to b divided by 10 to the power a. And those things are equivalent to each other.